All right, so we are going to focus on the graphs of sine and cosine. So they look very similar. These are called periodic functions because they make that continuous wave pattern. So the domain of these will be negative infinity to positive infinity. That wave pattern is going to continue to the left and right forever and ever and ever. I am going to trace this a little bit darker. All right, and if you notice, I'm going to zoom in a little bit. The y-axis is just regular numbers like we use on a y-axis all the time. But if you notice the x-axis, what are those? Pi. What about the version that's underneath it? Degrees. So your x-axis is in degrees. Do you remember what we call an angle when it's in terms of pi? Radian. So your x-axis is going to be in either degrees or radians. And the parent function goes from 0 to 360, a full circle, one full cycle. 2 pi is the same as 360. Remember, 2 pi r is the circumference of a circle because 2 pi is the radian measure. All right, so what makes these two graphs different? The way you can tell the difference between sine and cosine. Sine should pass through like whatever your origin is. I'm going to put origin in quotation marks because we're going to be shifting the graphs up and down. Are we supposed to see that? Sorry, Olivia, yeah. Okay, let me see if this works. Can you see him now? Yeah, thank you. You're welcome. Okay. So I'll leave that up there for a second. But that's so far, we haven't really done much. So sine should pass through the origin. Whereas for cosine, if I'm looking at the y-axis as my initial value, cosine should start at the maximum or the minimum if it's flipped upside down. So cosine will have the maximum or the minimum on the y-axis. All right, the equations that we use are going to be the same. In the next box is where I'm going to actually explain the equations. And this one is just the same thing, but cosine. All right, and so your domain is always going to be negative infinity to positive infinity because we can go infinitely many times around a circle. Negative around the circle is counterclockwise. So that's why your degrees and radians are a negative. It just means you went around the circle the opposite way. The range depends on the graph. But you should be able to see like an upper imaginary boundary line and a lower imaginary boundary line. So those maximums and minimums, there's not going to be any higher or lower maximums and minimums on the parts of the graph that you can't see. All right, so key features. So this is the transformation part of the equation. So every letter that you see in here is doing something to the graph. Either stretching it, like making the maximums and the minimums higher and lower. It could also be stretching it out horizontally, making the wavelength longer or making the wavelength shorter. Could be shifting the entire graph up and down, or it could be shifting the entire graph left and right. So this is just a little picture that kind of points out what all the letters mean, and we're going to kind of draw on the graph where we're seeing that on the graph. So A is the amplitude. The amplitude is the distance from the midline to the maximum or the minimum. So it's kind of faint on your copy of it. This was as dark as I could make the picture. But that line that's going through horizontally, it's going through the middle of the graph, that is the midline. And it's the horizontal halfway point. So the amplitude would be, I'm kind of drawing over it because it's pretty faint anyway. So the amplitude is basically from the middle of the graph to the maximum, and it's supposed to be halfway. So it should be the same as if you go from the middle to the minimum. Amplitude is always positive. It represents a distance. So even if there's a negative sign there, that doesn't make the amplitude negative. It just means that your graph has also been reflected. But amplitude needs to be positive. So the vertical shift of the graph is that plus or minus that's at the end. And the vertical shift moves the midline. So that plus or minus number that's at the end is going to tell you where your midline is. So when you see a question asking you about the midline and then also asking about the vertical shift, it's essentially the same question. I will tell you, because I'm pretty sure your Delta Math wants the equation of the midline. The midline equation, because it's just a horizontal line, should be y is equal to whatever that vertical shift number is. So when it asks you for the equation, all right, your phase shift is the number that's in parentheses with the x. Now I want you to notice very carefully that x has nothing in front of it. The B is on the outside. So you can only tell me a left shift and a right shift if there's nothing in front of the X. So that C, that arrow is going down here. That is your phase shift. And if it's plus, it moves it to the left. If it's minus, it moves it to the right. All right, so the last thing is the period. The period is related to the B number that's on the outside, but it's not equal to the B number. So the period is usually where we need to spend kind of the most time figuring it out. There's a formula here to figure out the period. It's equal to 2 pi over B, or 360 over B if it's in degrees, because 2 pi and 360 are the same. It's just one is in radians and one is in degrees. But the period is essentially like the wavelength. So it's important that you kind of remember what that sine curve looks like and what that cosine curve looks like. Basically, we're looking for a starting point, and we're going to follow the curve until I get back to like the same position. It should almost look like we're making a pattern, like subway tiles. So I would not pick someplace hard on the graph. Like I wouldn't pick like here to try to figure out what my period is. I would want to pick either a maximum, a minimum, or a point that's actually going through the midline. Those are my key points that I would want to look for. So if I use this as my starting point, that is one full wavelength. Because I can just take what I just colored purple and just copy and paste that, and it will continue the rest of the graph. So the period is essentially like the wavelength. And it's either 2 pi over B or 360 over B.